demand. Now, to understand the concept of Marshallian and Hicksian demand curve, we would be going through a set of utility functions. First of all, what is utility? Utility is the satisfaction that you get from a commodity. I may get utility from my car. I may get utility from the laptop that I'm using. I may get utility from the book that I read. And this utility needs to be depicted. And it's depicted through the indifference curves that we study. What is an indifference curve? As the word suggests, indifference means equal. So an indifference curve shows you different combinations of two commodities. We call them as bundles. So it shows you different combinations of two commodities that give you the same level of utility. It is possible. So for example, when I have one car and maybe one house, it gives me the same utility as having no car but two houses. When I read 2 micro books and 10 maths books, it gives me the same utility as 5 math books and 5 micro books. So the bundles that give you the same level of utility are depicted by these indifference curves. There can be various types of indifference curves. For example, you can have an indifference curve which can be well-defined preferences. You can have indifference curve which are perfect substitutes. You can have indifference curve which represent perfect complements. You can have indifference curve which represents something which is known as a max function. You can have indifference curve which represents a combination of necessity and other goods, represented by a quasi-linear indifference curve. For each of these indifference curves that we have, we want to go ahead and map them to what is the criteria when we use that indifference curve. Secondly, how do we find Marshallian demand curve for each of these indifference curves? How do we find Hicksian demand equation for each of those indifference curves? How do we find direct utility, indirect utility, expenditure function for each of these indifference curves? So my aim is to cover these indifference curves and to understand how to find all of these things for different indifference curves. Let us try and begin with the first one, which is well-defined preferences. For well-defined indifference curve can be written of this format. Let's write down U is equal to X, Y. It's also called the Cobb-Douglas indifference curve. Now, as we progress, we'll understand that this is just one type of Cobb-Douglas indifference curve. You can very well have U is equal to X to the power alpha, Y to the power beta, and alpha and beta can take different values. Here, alpha is taking the value 1, beta is taking the value 1. So your utility function really is simply X or Y. But it may not be always the case. You could very well have a utility function which says X to the power half, Y to the power half, X to the power 3 by 4, or Y to the power 3 by 4, etc. It may also not be the case that alpha plus beta is always 1. For example, here, Alpha plus beta is 2. For example, it can be less than 1. I can have x to the power half, y to the power 1 by 4. All those cases are possible, but the methodology remains the same. What we do remains the same. But for now, for simplest calculation, I am just going to take my utility function as xy. Now, since this represents a utility function, we have to hold utility constant. So we can take any number. Let's say that I hold utility constant at 4. What does this mean? This means that x into y is equal to 4. So I really have to make all those combinations of x, y such that when I multiply them together, I get 4. So I can have my x as 1, y as 4. I can have my x as 2, y as 2. I can have my x as 4, y as 1. Can I have x as 0? No. 0 into anything can never give you 4. So which means I cannot have my x as 0. Can I have my y as 0? No. Because again, 0 into anything is not a positive number. So which means that whenever I will plot this kind of indifference curve, u is equal to xy, I cannot touch x or y axis. When you intersect the x-axis, y is held constant at 0, which is not going to happen here. Otherwise, I won't get a utility of 4. When you intersect the y-axis, x is 0. Again, it cannot happen here. So because x and y cannot be 0, you cannot intersect the x or the y-axis. So the curve that you get is something like this. It may approach the x and y-axis, but it will never cut the x or y-axis. So I can have this as x or y. This is good x. This is good y. And this indifference curve is really a rectangular hyperbola. It goes ahead and it tries to touch the x or the y-axis, but it really does not intersect the x or the y-axis. It can go till, so you can have an x equal to maybe 10,000. So your y will be 0.004 and so on. You can multiply it and get 4. That's possible. X can be huge, y can be small. Y can be huge, x can be small. But x cannot be 0 and y cannot be 0. That's not possible. So you get something like a rectangular hyperbola. Usually, for well-defined indifference curve, I will always plot them like this. This is what my well-defined indifference curve is. Now, once I understand what my well-defined indifference curve is, I want to introduce the concept of marginal rate of substitution. This is also known as MRSXY. What is MRSXY? MRSXY really is the slope of the indifference curve. The slope of any curve is measured at a point on the curve. So, for example, if I want to measure the slope of this curve here, I have to draw a tangent line here, and that will give me the slope. If I have to measure the slope here, I will draw a tangent line here and it will give me the slope. If I have to measure the slope here, maybe a tangent line here will give me the slope. So at any point of a curve, if I have to find out what is the slope of that curve, I will draw a line tangent at that point, and that will give me the slope of that curve. Now, what is a slope really? A slope is always perpendicular by base. Perpendicular by base. So in this case, also the slope of the indifference curve is perpendicular by base. But it has a name to it, and the name is marginal rate of substitution. And what does it tell us? So it tells us the rate at which individual is willing to substitute one good for another. See here, I want to hold my utility constant at 4. As you increase the consumption of good X, you are taking good Y from me. You're increasing X for me, but you're taking away Y from me, such that my utility is held constant. So initially, I had 4 units of Y and just 1 unit of X. My utility was 4 into 1, which is equal to 4. As you gave me more X, you increased my X to 2. You took Y from me, such that again 2 into 2 is 4. Utility is held constant. As you gave me more of X, you kept taking Y from me, such that I hold the utility constant. However, as you keep on giving me more and more of X, I go from point A to B to C to D. My willingness to have more X is there, but to give away Y is low. Initially, at point A, I had a lot of Y. So I was willing to give a lot of Y just to gain 1 additional unit of X. See, I'm willing to give so much of Y given by the distance perpendicular just for 1 unit of X. Because at A, I have very less of X. I have a lot of Y. But as I go down the indifference curve, maybe when I'm at B and I want to go at a point like E, I don't want to give you a lot of Y for 1 unit of X. Because you have already taken my Y from me. I just have very less of Y left. And again, you're asking me to give more Y for an additional unit of X. So as I go down the indifference curve, my willingness to give more and more of Y for an additional unit of X decreases. I don't want to do that. So therefore, my rate of substitution also decreases. This is called diminishing MRS. As you go across the indifference curve, your willingness to give Y for an additional unit of X decreases. Now, if we go back to the equation, my utility function is U is equal to XY. If I ask you to total differentiate this function, you will get du is equal to how utility changes when x changes, dx plus, and in fact I will write a general form so that you can apply it to all. The function of x and y. So how utility changes when x changes dx plus how utility changes when y changes dy. Please understand this thing. My utility is gained from two commodities, x and y. When I ask you the question, how utility changes, you will tell me that how will utility change? You will go from point B to point C. And when you will go from point B to C, then x is also changing and y is also changing. So utility is changing because x is changing into how much x is changing. Plus, utility is changing because y is changing into how much y is changing. This is the total differentiation of your utility function. Now, along an indifference curve, there is no change in utility. We had held utility constant. So my du becomes 0. This part right here is how utility changes when x changes, and this is known as marginal utility from x. The additional utility you get when you consume one more unit of x into dx plus marginal utility from y into dy. You solve for this and you get minus mux dx is equal to muy dy. And from here, you get dy by dx is equal to minus mux by muy. If I go back and I check, the slope of the indifference curve was perpendicular by base. Perpendicular was change in good y. Base was change in good x. So the slope really was dy by dx. So here is my slope. And the value of the slope of indifference curve is minus mux by muy. So this is the slope of the indifference curve. You must at all times remember this formula. Very important. The slope of the slope of the indifference curve or the marginal rate of substitution is mux by muy. Mux is how your utility changes when x changes. Muy is how utility changes when y changes. Just one thing that I want to alert you here. You can only find this for differentiable functions. If you cannot differentiate your function, you cannot find mux and muy the way that we are doing here. We'll talk about those functions also, which are non-differentiable. But now, understand that if the function is not differentiable, you cannot find mux and muy. Okay. Any doubt that we have till now? What is an indifference curve? What is the slope of indifference curve? What is MRS? Any doubt? Are we good? Okay. Now, let's go ahead and talk back about our utility function that we started. So the utility function that we have is u is equal to xy. One property of this utility function is related to the consumption bundle. See, this schedule that we plotted, that when x is this, y is this, when x is 1, y is 4, x is 2, y is 2, I could have gone ahead and I could have written that when x is minus 1, y is minus 4, then also x into y is 4. But why don't I do this? This is because the consumption can always be positive. You cannot consume negative units of any commodity. The consumption has to be positive. And because the consumption has to be positive, we can write that the consumption bundle is Rn plus. Now let's see what this means. See, R usually represents the set of real numbers. When I write R plus, it represents the set of positive numbers including 0. When I write R plus plus, it represents positive numbers not including 0, strictly positive numbers. Now, this N here, this represents the dimension. So when I talk about N commodities, I will write Rn plus. When I talk of only 2 commodities X and Y, I will simply write it in the R2 space. If I want to talk about 3 commodities X, Y and Z, you will talk about R3 space. Usually, in any question, they will mention it to you that the consumption bundle belongs to Rn space or the consumption bundle belongs to R2 space. There is nothing to worry there. You just have to understand that this represents the number of commodities. Ideally in maths, this represents the dimensions. But here, this represents the number of commodities. Okay. Now, once we have this utility function with us, I want to go ahead and optimize my utility. This optimization is always a constrained optimization. What is a constrained optimization? That you want to maximize your utility, but subject to a budget constraint. You have some constraint in mind. You cannot exceed your income level. Within your income, you have to buy your bundle. So your aim is to maximize your utility subject to your budget constraint. This budget constraint is nothing but price of good X into X plus price of good Y into Y less than or equal to the income of the consumer, where this is the money that you are spending on good X. This is the money you are spending on good Y. This is the total expenditure of the consumer. And this expenditure cannot exceed the income of the consumer. It has to be less than or equal to the income. Though, whenever we solve it, I will always take it with equality. I will not take less than my income. I will always assume that I am on the budget line, not below the budget line. And I can very well extend this to an N commodity case. So I can very well go ahead and say that Px into X plus Py into Y plus Pz into Z and so on till Pn into N, Xn is equal to income. So I can extend this. I mean, this is just an expenditure on N commodities. But for our purpose, we will always do this. And as far as the exam is concerned, The maximum that has come till date is this: px into x plus py into y plus pz into z less than equal to m. This is something that has been asked in 2017 DSC exam, 2019 DSC exam. This kind of budget line has been asked. So, they don't extend. We can extend it to n commodities. The concept remains the same, but we usually do it for a 2 commodity or a 3 commodity case at max. The idea is for you to understand what is constrained optimization, and then you can do it for any commodities. Now, when we talk about maximizing utility, subject to budget constraint, there are 3 methods in fact. Method 1, 2, and 3. All of these are going to yield the same answer to you. They're just the same thing done in different ways. The first method is by substitution. The second is by forming Lagrange. And the third is by using utility maximization equation. I would always prefer to go with Lagrange because this is easily extendable to many good cases. But it is not to say that if you go ahead with this or this, it is wrong. For this case, I'm going to show you all the 3 methods. Then it is up to you whether you want to go with this or this or this. They're doing the same thing. So let's take method 1. So my aim is to maximize u equal to xy subject to px into x plus py into y is equal to m. In method 1, you want to bring the utility function in only one variable. So what are you going to do? You are going to find the value of y from your budget line. So y will be m minus px into x by py. And after finding the value of y, you will substitute it in the utility function. So your utility function will become x, and instead of y, you will write m minus px into x by py. So from the budget line, you bring one variable in terms of other, and then substitute it in the utility function. Notice that the entire utility function is now only in terms of x. And now you will do basic optimization. How do you maximize your utility? Differentiated, equate it to 0. That's class 11, 12th maths, basic maths of maximizing functions. So you will simply, in order to maximize your utility, you will simply differentiate your utility function with respect to x. So you will get m minus 2 px into x by py. This is simple, right? This is m into px minus px into x square by py into x. So differentiation of m into x is just m. Differentiation of x square is 2x into px, equated to 0. And from here, you will get x is equal to n by 2px. You've got x, you know what y is, you will put back x there. So y is m by py minus px into py into x. So this will be m by py minus px by py into m by 2px. So this will be m by 2py. This will be a y star. So you will get your x star and y star as m by 2px, m by 2py. Simple. From the budget line, you found the value of y, substituted that y back in the utility function. The entire utility function was only in terms of x. Once the entire utility function is in terms of x, you maximize the utility function, differentiate it with respect to x, equate it to 0, get x, put that x back in the y and get y. That's method 1 for you. You can very well follow this method to find x star y star, the combination that maximizes utility. Now, method 2 is Lagrange. Now, Lagrange in itself is a full-fledged topic that we do in maths. However, for us currently, we just want to understand a very basic level of Lagrange that can be used in microeconomics. So how do we solve about that? We form a Lagrange. It's represented by N. We write two parts to Lagrange. The first part is my objective function. And the second part is my constraint. Constraint is always followed by Lagrange multiplier, and you always have a plus sign in between. This Lagrange is differentiated with respect to all the variables that you have in mind, but it is also differentiated with respect to the Lagrange multiplier. Ideally, whenever you will differentiate with respect to Lagrange multiplier, you will actually get back your constraint. There is nothing different that is going to happen here. You will get back the equation of the constraint. After differentiating, you are equating each one of these to 0. Because that's how you optimize. You differentiate it and equate it to 0. Let's see in our case. So I form a Lagrange. The objective function is the utility function plus lambda. My constraint was px into x plus py into y is equal to income. In order to rewrite the constraint inside the bracket, you always bring this side on the other side. So you always have your constraint like this: m minus px into x minus py into y. Forming this equation is what you have to learn. After you have formed this equation, it's pretty simple. You differentiate this Lagrange with respect to x. You will get y plus lambda minus px is equal to 0. So you will get y is equal to lambda px. You differentiate this Lagrange with respect to y. So you will get x plus lambda minus py equal to 0, which means x is equal to lambda py. You differentiate this Lagrange with respect to the Lagrange multiplier, which is lambda. So you will get m minus px into x minus py into y equal to 0. which means you will get M is equal to Px into X plus Py into Y. Always divide the first and second equation. So 1 by 2 will give you Y by X is equal to lambda Px by lambda Py. And when you will solve it, you will get Y into Py is equal to X into Px. This equation is of utmost importance. Very important. What do you think this equation suggests? Y Py is equal to X Px. What can this equation mean? Think Y is the number of units of good Y that you buy. Py is the price of each unit. So this really tells you what is the expenditure on good Y. And this tells you what is the expenditure on good X. And the two are equal. This is a very important property of well-defined preferences. The expenditure on the two commodities are the same. Whatever amount of money you are spending on good X, exactly same amount of money you are spending on good Y. So if an MCQ question comes, you should not waste your time solving that there are two commodities X and Y with well-defined preferences and income of consumer is 200. What is the expenditure on each commodity? 100 each. The expenditure on good Y is same as the expenditure on good X for well-defined preferences. Now, I have got this. XPX is equal to YPY. I also have a third equation that XPX plus YPY is equal to M. So I'll substitute here. Because XPX is equal to YPY, here also I will write XPX equal to M. And I will get 2XPX is equal to M. And I will get X star is equal to M by 2PX. And since XPX is equal to YPY, I will get M by 2PX into PX is equal to YPY. So I will get Y star is equal to M by 2PY. So whether you solve it using method 1 or method 2, you're getting the same answer that X is equal to M by 2PX and Y is equal to M by 2PY. You're able to solve this much. There is one last method that I want to do. I'll not do all these three methods for every question. I leave it up to you to use any method you want to. But for the first question, we'll do through all the three methods. So method 3 really depends on, it relies on the equilibrium that we get in case of consumer. So how do we really get consumption equilibrium? So we have a budget line. We try and attain the maximum or the highest indifference curve possible. And we reach that highest indifference curve at the tangency of budget line and indifference curve. So the equilibrium condition for a consumer is always where budget line is tangent to indifference curve. Tangency always means that the slope are equal. What is the slope of budget line? It's Px by Py. What is the slope of indifference curve? It is MRS xy. So at equilibrium, the two are always equal. What is MRS xy? I'm taking in absolute terms, not with negative sign. So MUX is equal to MUY. What is MUX? Differentiate utility function with respect to x. What is MUY? Differentiate utility function with respect to y. Let's just put it. What is your utility function? X into y. What is MUX? How utility changes when x changes, which is nothing but y. Because when you differentiate this with respect to x, y is held constant. So you will only get that constant. And what is MUY? Differentiate utility function with respect to y. X is held constant, so you will get x. So this will become y by x. And now just put it here. So you will get Px by Py is equal to y by x. So you will get x Px is equal to y Py. Now, if you notice, this is exactly the same equation that I got in case of Lagrange. That x Px is equal to y Py. This is the same equation. So you have been getting the same equation that either that Lagrange gave you, simply equating MRS to Px by Py gave you. You've got the same equation. Now you just have to put this equation in the budget line. So your budget line is x Px plus y Py is equal to m. You just equate because these two are equal. So instead of y Py, you will put x Px equal to m. And you will get x star is equal to m by 2 Px. Y star is equal to m by 2 Py. The same answer. So let's just revisit what we have done. We are trying to maximize the utility subject to the budget constraint. I am trying to find out that x star y star that gives me maximum utility. In order to find the x star y star that gives me maximum utility, I have to maximize utility subject to budget constraint. I can do it by the method of substitution, Lagrange, or consumer optimization equation, MRS equal to Px by Py. Either ways, whichever method you use, you will get the same answer. So diagrammatically, this just means that if I have this as my budget line, and I have this as my indifference curve, then this is my x star, this is my y star, this is equal to m by 2 px, and this is equal to m by 2 py. This is how we find x star and y star. These x star and y star that you just obtained are called Marshallian demand functions. Okay, so it's known as Marshallian demand function. That X star Y star that maximizes utility. Any doubt that we have till here? Any doubt? Anything that you want to ask? Okay. So once we have, yes.
Okay, ma'am, I have a doubt, ma'am.
Tell me.
You mentioned a list of multiple types of indifference curve. Is that list exhaustive, or are there any other type of indifference curve that are there?
Okay. There are many more. For example, I can go ahead and draw a concave indifference curve, which would be for a function where my two goods are bad good. I can draw an indifference curve between two goods, one being a good and one being a bad good. That is possible. I can have different indifference curves for different kind of commodities, but these are the most used indifference curve as far as your level. I mean, the level till the entrance exam or master's exam is concerned. These are the indifference curves that we would be using. So this is not a completely exhaustive list. We do have many more type of indifference curves.
Thank you, ma'am.
Okay. So now, okay. Now let's go ahead and talk about the indirect utility function. See, we started with a case where u was equal to xy. When u is equal to xy, this is called direct utility function. A direct utility function will always directly tell you as a function of the commodities, as a function of the goods x, y, z, min of x, min of y, etc. Now, once you have found this x star value, which in my case was m by 2 px, and this y star value, which is, in our case, m by 2 py, you can go ahead, put these values in the utility function. So, in our case, it will be u equal to m by 2 px into m by 2 py, which is equal to m square by 4 px into py. This utility function that you obtain as a function of income and prices, this is called indirect utility function. So the indirect utility function is basically a utility function which is a function of income and prices. Ideally, what is this saying? See, I found that x star which maximizes my utility and that y star that maximizes my utility. I have plugged in those best values in the utility function. So the indirect utility function really is the maximum utility that you can obtain. What is the maximum utility possible within your income, within your budget? That is called the indirect utility function. Let's now write down certain properties of indirect utility function. Very important property. First, see, if you would notice, M in the indirect utility function is coming in the numerator. Of course, as your income increases, your utility should increase. And if not increase, it should not definitely decrease. So for example, if my income increases from, let's say, 1,000 to 1,050, maybe I'm not very happy, but it won't decrease my utility. So my utility will maybe remain the same. And supposedly my utility, my income increases, let's say from 1,000 to 5,000, then it is definitely increasing my utility. So income will definitely either increase your utility or at least keep that constant. Will never decrease your utility wherever income increases. So we can say, write down, that indirect utility function is increasing, and if not increasing, then definitely non-decreasing in income. Let's take what is the indirect utility in our case. It was m square by 4px py. Let's differentiate this with respect to m. What will I get? I will get 2 into m by 4px py, which is m by 2px py. M is positive, px is positive, py is positive. So this entire thing is positive. So which means as income increases, indirect utility is increasing. It's a positive function, increasing function. So as this increases, shown by a positive sign. Okay, that's the first property. Write down the second property. Indirect utility function is decreasing, and if not decreasing, then definitely non-increasing. Does not increases for sure with prices. Which means when prices will increase, your utility will decrease. And if not decrease, definitely it will not increase. Again, take your utility function. It is m square by 4px py. Differentiate this function. You will get del v by del px is equal to, now see here, this is px is coming in the denominator. So differentiation of, and if you want, I can also write this as m square by 4py into 1 by px. And differentiation of 1 by px will be minus 1 by px square into m square by 4py. Clearly, because of this negative sign, this is less than 0. And you can show this for py also. So del v by del py will be minus 1 by py square into m square by 4px, which will be less than 0. So it's a decreasing function of prices. As prices will increase, your utility will decrease. It makes sense. The more the price that I have to pay, the lower my utility will be. So this is the second property of indirect utility function. This is the first property. Write down the third property. indirect utility function is homogeneous of degree 0 in price and income. Let's understand what is homogeneity. Homogeneity means when you double your income and your prices, because I'm saying in M and P, what happens to your utility function? Now, it's not always you have to double. You can triple also. You can multiply it by any scalar also. Now, if that scalar, and this is something that we have done in maths, but we'll do it in maths again. So if that scalar comes out of the function, for example, when I say that my utility function in this case is m square by 4 px py, and now I find my utility function by scaling everything with p. So instead of m, I write pm. Instead of p, I write pp. Instead of py, I write ppy. Or, and I just see what comes out. So this is t square m square upon 4 into t square px py. So t square gets cancelled, and this is simply m square upon 4 px py, which is nothing but t to the power 0. Anything to the power 0 is 1. So t to the power 0 upon 4 px py. This is nothing but t to the power 0 into initial utility function. So I have multiplied everything with t, and I am getting back my original utility function, and the power of the scalar that I got out is 0 in this case. I will show you when the power is 1 also. But in this case, it is 0. Because the power is 0, we can say that it is homogeneous of degree 0. First of all, you should be able to get the scalar out. If you are not able to get the scalar out, it is not homogeneous. Second, once you are able to get the scalar out of the function, what is the power of the scalar? Whatever is the power of that scalar, that is the degree of homogeneity. In this case, because the scalar has a power 0, it's homogeneous of degree 0 in prices and income. This is tricky. In one of the papers of BSc entrance exam, there was a question which said that the indirect utility function is, and you have to tell the right statement, and it said it is homogeneous in prices. One said in income. One said in income and prices. So you have to identify that I have doubled or multiplied by both M and P. I did not go ahead and just scale M or just scale P. No, that is not what I am doing. And it also mentioned of degree 0. Right? So I am going ahead and scaling both M and P simultaneously. Had I scaled only M and not P, then T square would have come out. That would have become homogeneous of degree 2. That's not what I am doing here. I'm scaling both M and P simultaneously, and actually only this is a property which holds true for different functions. If you scale only M or P, then that homogeneity will not hold across functions. You will see you will get different degrees for different utility functions, but you will always get homogeneous of degree 0 whenever you scale M and P simultaneously, irrespective of which utility function you talk about. Whether it is perfect substitute, perfect complements, your well-defined function, any function, this property will always hold. So you have to identify the right answer. It is homogeneous of degree 0 in M and P. That's the property. Okay. Write down the fourth property. VPM is quasi-convex in P. This is something which you can only do after we have done the maths video. So I will hold this thing for now. I will tell you which videos to refer to while I am revising this concept from maths. But please understand, there are two types of functions. One is concave, one is convex. We understand about concavity, convexity based on double differentiation of the functions. But quasi-convex and quasi-concave are not the same as convex or concave. They are near convex or near concave function. And to understand those, we have to understand what is a Hicksian matrix, how do we go about those Hicksian matrices, etc. So, we will park this for now and only come back while we do this concept in maths. But these are the four main properties that you have to remember. So let's just revisit them. It is non-decreasing in income, non-increasing in prices, homogeneous of degree 0 in prices and income, quasi-convex in prices. These are the four main properties of indirect utility function. Now, you have been able to start with a direct utility function, find the optima x star y star, from there find indirect utility function. Now, once you find this indirect utility function, you can go ahead and find a corresponding expenditure function. So the question is, what is expenditure function? See, look here. We found out our indirect utility as n square upon 4px py. This is the maximum utility that you can get from your utility function. Supposedly, I go ahead and write this as u bar because this is the maximum utility I can get. And along an indifference curve, it's held constant at u bar. So I will get u bar is equal to n square upon 4px py. If from here I find m, what will I get? I will get m is equal to 4px py into u bar under root. So I will get this as 2 under root px py u bar. This function thus obtained, this is known as the expenditure function. What is an expenditure function? An expenditure function tells you what is the minimum money required to fetch a given level of utility. So if I have this much money with me, M is equal to this much, right? If I have this much money with me, then I will be able to get this utility U bar. That is what this function is saying. So I can say that my expenditure function, which is a function of prices and utility, can be written as 2 under root Px, Py, U bar. This is my expenditure function. So how do we find expenditure function? You find your indirect utility function and you just rewrite M in terms of U bar and you get your expenditure function. Now, let's try and analyze this thing diagrammatically once. So see here, a consumer problem can be considered in two parts. Either you can maximize your utility subject to budget constraint. This is what we do. From here we find X star, Y star. Or you can go ahead and minimize your expenditure subject to given level of utility. Both of these problems are actually duality problem or dual problem. They solve the same thing. You're doing exactly same thing. But when we use this technique and when we get the optima values from here, that is known as Hicksian equilibrium. Whereas when I use this to find the optima, I get Marshallian equilibrium. So let's see this. What am I doing in this case? I am saying this is my income. My income is represented by my budget line. My budget line is this. Px into x plus py into y is equal to m. So here I have m by px, m by py. This is x, o, y. This is my budget line. And I want to attain the maximum utility possible. So I go to the first indifference curve and I ask the question, can I go higher? The answer is yes. I go to this indifference curve. I ask the question, can I go higher? The answer is no. This is the maximum utility I've attained. So I hold my income constant and I try and attain the maximum indifference curve possible. This is this method that you do. Now come to the second method. Here, what you're doing is, you are saying, look, I want to attain this U bar utility at any cost. This is what I want to attain. Tell me what is the minimum money in which I can attain this. Is this the minimum money? No. You can go a little below. Is this the minimum money? Yes. If I go below this, I won't be able to achieve this utility. Again, it gives you the same tangency condition only. But the technique has changed. I draw various budget lines and see where am I reducing the expenditure to achieve this level of utility. Here, I draw various indifference curves and see where am I achieving the maximum utility. We have done this technique. From this technique, we got x star is equal to m by 2px y star is equal to m by 2 py. And the maximum utility we got was n square by 4 px py. Now, if I tell you and I ask you how to use this technique, my problem reverses. I want to minimize the expenditure, so px plus py. This is what I want to minimize, the money that I spend, subject to the constraint that my utility that I obtain should at least be u bar. This was my utility function, right? xy. I want this utility function to be equal to u bar. And I want to minimize this. Again, you can use any method, substitution, tangency, whatever you want. I'll form a Lagrange and so I will say my Lagrange is px into x plus py into y plus lambda u bar minus xy. And I will form my equation. So first I will differentiate this with respect to x. I will get px plus lambda minus y equal to 0. From here I will get px is equal to lambda y. I'll solve this Lagrange with respect to y. So I will get py plus lambda minus x is equal to 0. So I will get py is equal to lambda into x. And then I will definitely solve it with respect to multiplier. And I will simply get u bar is equal to xy. This is equation 1, equation 2. I will divide 1 by 2. And from here, I will get y is equal to x into px by py. This will get cancelled. I will simply put this value here. And I will get u bar is equal to x into px by py. And x square into px by py is equal to u bar. So I will get x is equal to py into u bar by px under root. You can solve for y also from here. You will get y is equal to px by py into u bar. This x and y that you have got by minimizing your expenses subject to a given level of utility, this x and y, this is called Hicksian demand curve or demand function. The Hicksian demand function is a function of the utility and prices. Please note this thing. It's a function of utility and prices. You hold utility constant, whereas the Marshallian demand function is a function of income and prices. You must remember this at all times. Marshallian is always a function of income and prices. The Hicksian demand is a function of utility and price. This. So how did we find the Hicksian demand function? We minimized the expenditure subject to given level of utility. Now, there is another method to get the Hicksian demand function. And we got a question on this actually in IIT JAM exam of 2021. And this is known as the Shepherd's lemma. What does this suggest? This lemma suggests that in order to find the Hicksian demand function, you just have to find out the derivative of the expenditure function with respect to the price, and whatever you will get will be the Hicksian demand function. You have to differentiate the expenditure function with respect to prices, and what you will get is the Hicksian demand function. We were able to find the expenditure function. See here, this was my expenditure function, 2 root px py into u bar. Just differentiate this with respect to px once, you will get 2. So root px is coming here. Differentiation of this will be 1 by 2 root px into u bar py under root. And if you solve this, you will get py by px u bar under root. And you can go ahead and clearly see that this is exactly what I got after solving through this method. Py by px u bar under root. And that is exactly what I am getting by differentiating my utility function. So this is what the Shepard's lemma suggests, that you just simply differentiate your expenditure function with respect to the prices, and you will get your Hicksian demand function. So, what is the entire process that we have learned so far? I am given a direct utility function. I find x star and y star from it. I put it back in the direct utility function, and from there I find indirect utility function. After I find the indirect utility function, I rewrite this such that m is a function of utility and prices. I call this m as the expenditure function. I differentiate this expenditure function with respect to prices, and I get the Hicksian function, Hicksian demand. The initial demand function that I got, this is actually Marshallian. It's a function of income and prices. And the final demand function that I got, Hicksian, it's a function of utility and prices. This is a full-fledged question that can come in various forms. They can ask you to find the Hicksian demand function, to find the Marshallian demand function, to find the expenditure function. They can give you the expenditure function and ask you to find the indirect utility function. They can ask you in different formats. You have to be clear with all the steps that we have gone through. Now, as an exercise, once you revise this lecture, I want you to go ahead and solve this for this utility function. I have done it for xy. I want you to do it for root xy. What will you find? Direct utility function is given. From there, you will find Marshallian demand. Then you will find indirect utility function. And then you will find the expenditure function. And finally, from there, you will go ahead and find Hicksian demand. So you have to go ahead and follow this entire process and get the answer for this. Try it for at least 2 to 3 different utility functions. Try it for u equal to x to the power 1 by 4, y to the power 3 by 4. And tell me what you're getting as the answer. Okay, you get very similar formats. And try it for a general case also. X to the power alpha, y to the power beta. Try and show that the Marshallian demand curve, I am giving you the answer, will come as x star is equal to alpha upon alpha plus beta m by px, and your y star will come as beta upon alpha plus beta m by py. So this is the answer that you will get. And once you remember this actually, this general format, alpha upon alpha plus beta and beta upon alpha plus beta, you can solve it for any alpha beta. Your alpha is 1 by 4 here, beta is 3 by 4 here. So you know that for this the answer will come 1 by 4 upon 1 m by px and p by 4 upon 1 m by py. So you will be able to solve it for any place. So I want you to go ahead and take at least 2 to 3 different utility functions and follow this entire process. Okay. Any doubt that we have? Anything which is not clear? Okay. Now, let's go ahead and look at the expenditure function one last time. So the expenditure function that we had in our case was this. E of PU is equal to, we had got 2 root px py u bar. 2 root px py u bar. Right? Let's write down the properties of the expenditure function. So what are the properties that we have? First, the expenditure function is increasing. And if not increasing, then definitely you can say non-decreasing. They're the same thing with a slight difference. So it is increasing in prices. And how do I show this? As I differentiate my expenditure with respect to Px, I have to see what is happening to my function. So, if I differentiate my function, I will get 2 py by px u bar under root without 2 actually. And because this is strictly greater than 0, so it's an increasing function. You can show that del E by del Ey is equal to px by py u bar, again greater than 0. So the expenditure function is increasing in prices, which means that when you differentiate the function, you get it greater than 0. Second property. The expenditure function is increasing, or at least you can say non-decreasing, in utility. Again, it's very simple to interpret. The more the utility you require, the more the expenses you will have to make. So let's go back to the expenditure function, which was 2 root px py u bar. And now let's find del E by del u bar, and I will get 2 px py under root upon 2 root u bar, which is clearly greater than 0. So it is increasing even in utility. Now, let's go to the third property. This is related to being homogeneous. So, my claim is that the expenditure function is homogeneous of degree 1 in prices. And I want you to just try this with me. So supposedly we start with an expenditure function that we just found out, 2 root px PYU bar. And because I'm saying it is only in prices, I will just double the prices or scale up the prices. So I will say V of TP comma M will be 2. Instead of PX, I will write PPX. Instead of PY, I will write TPY into U bar under root. So this will be 2 P square PX PY U bar. So T will come out. It will be 2 root Px Py U bar. And this will simply be T to the power 1 into the initial expenditure function. Just write this as E so that you don't get confused. So because this is, and here also you can write U bar. Because T has a power of 1 attached to it, we can simply go ahead and say that it is homogeneous of degree 1. The expenditure function is homogeneous of degree 1 in prices. Question to you. Please try this. Can you state anything related to homogeneity in utility? Is it homogeneous in utility also? Please check it out once. Is it homogeneous of any degree in utility when you only scale the utility? So just try this. Your expenditure function is 2 root Px Py U bar. And now instead of U bar, you will write Pu bar, Px Py under root. And now, can T come out? Yes, you can have root T into 2 root Px Py U bar. So this will be T to the power half into the initial expenditure function. So the degree of homogeneity is half. However, this is not a property. In U bar, as you change function to function, as you go from one utility function to another, the degree of homogeneity will change. But in prices, the degree of homogeneity will always be 1. So this is a property, that it is homogeneous of degree 1 in prices, but this is not a property. Okay. All right. So with this, we come to the end of well-defined preferences. For well-defined preferences, what have we done? And now I'm just going to replicate this process in all my classes. So, this is the first step that you should understand well. You start with a direct utility function. You find X star, Y star. From that, you find indirect utility function. You rewrite M as a function of utility. This becomes your expenditure function. You differentiate your expenditure function with respect to prices, and you get your Hicksian demand. There are certain properties which your direct utility function holds, some properties of indirect utility function, some properties of expenditure function that you should be well aware of. Now, tomorrow, I am going to go ahead and follow exactly the same process for all other kind of utility functions, but you have to come well versed with this lecture, and you have to start reading chapter 2 to 6 of variant from my recorded videos, so that I don't have to kind of build the base. You still, when you're going through this, in your mind, okay, well-defined preferences is this, substitute goods look like this, complementary look like this. So you have to start going through it. I understand you cannot go through 4 chapters in a day, but you have to pick up the pace and maybe in 3-4 days, try and cover up these chapters too. Okay, thank you. Hi, good morning, everyone. Today I'm going to go ahead and continue with this Marshallian and Hicksian demand curve. So what we have done in the last class is a case of Cobb-Douglas function. We started with the direct utility function. We went ahead and found Marshallian demand. From Marshallian demand, we went ahead and found indirect utility function. We transformed the indirect utility function to find the expenditure function. And from this expenditure function, we went ahead and we found, using Shepard's lemma, the Hicksian demand function. This is the process that we followed to find the entire Marshallian and Hicksian demand. Now, today, let's go ahead and continue this and do this for the second scenario, which is the complementary goods. So I'm going to take a basic perfect complementary good utility function. Let's say that my utility function is u is equal to min of x, comma, y. Now, whenever you get a utility function like this, which is a min function, it is always referred for complementary goods. What are complementary goods? The goods that are used together. Like for example, left shoe, right shoe. For example, tea, sugar. For example, tea, milk. These are all complementary goods. They're supposed to be used together, pen and ink. Now, in case of complementary goods, in this min function that you are given, step 1 will always be to go ahead and find the kink. That's what the first step is. You find the kink of the complementary goods. The question is, how do we find this kink? In order to find the kink, whatever comes inside the min function has to be equated. And I'll tell you the reason why we do that. So for example, here, if I have x and y, I will equate x equal to y. And that will give me the kink line. Had my utility function been u is equal to min of ax comma by, then I would have equated ax equal to by, and this would have been my line of kink or kink line. This is how we solve it for complementary goods. Whatever comes inside the min function is supposed to be equated. Now, why is that the case? That is because of the very property of the min function. Take this example. For example, I take x as 4 and y as 5. Supposedly, I take y as 5. Then the min of 4 and 5 will be 4. I take y anything greater than 4, but I keep x constant at 4, I will always get the answer as 4. So whenever I have x less than y, then the min of x comma y is going to be x always. So the utility will be equal to the value of x, because that is what the min of x and y is. Now, for example, you have x greater than y. Again, my utility function will be min of x comma y. But now between x and y, minimum is y. So my utility will be equal to y. But if x and y are equal to each other, then the utility, which is minimum of x comma y, will simply be x or y. We have to remember this. We have to see this pattern carefully. Now, what does this mean? This means, in very simple terms, if I take left shoe and right shoe, if I have x as the left shoe and y as the right shoe, I can have 5 right shoes and 4 left shoes, but that will only give me 4 pair of shoes. 1 right shoe would be additional. I can have 4 left shoe and 10 right shoe. Still, I will only be able to make 1 pair. So, irrespective of how many y's I have, as long as x is less than y, that's the number of pair of shoes I will get. Just an example of complementary goods. Supposedly, it's the reverse. Y is 4, but x is 5. Then also I will make 4 pairs only. The 5th shoe would be of no use to me. But if x and y are equal, then also I will have the same pairs, 4 pairs. So ideally, I am saying that if I need 4 pair of shoes, I can have 1, 2, 3, 4, 1, 2, 3, 4. Either you can give me 4 pair of both left and right. I'm taking left here, right here. This is my x, this is my y. Or you can give me 5 of right, 6 of right, 7 of right. But keep left at 4. All of them will give me 4 pair. Or you can keep right at 4 and give me 5 of left, 6 of left, 7 of left. Then also it will make 4 pairs. So actually, if I jot down all these points together, I will get an L-shaped curve. It would be king at x equal to y. That's the number of pairs I will be able to make. You keep on increasing x, holding y constant at 4, I will have the same number of pairs. You keep on increasing y, holding x at 4, I will again have 4 pairs. So this point, this point, this point, this, all of them give you the same level of utility. They give you the same level of shoes that you have, the same pair of shoes. Now, because of this, we can also kind of think of a kink line passing through x equal to y. So I have a line, and this line is where x and y are equal. So for example, if I take 1 here, and I take 1 here, I take 2 here, and I take 2 here. This is the line of kink that I have. This line of kink divides my space in 2 parts. This is part A of the space, this area, and this is part B of the space, this part. If I carefully notice, then this side of the space, if I take any point, supposedly I take a point like this, here. This part of the space has x which is more than y is 2, x is 3. So throughout the right hand side, I always have x greater than y. You take any point in this green zone. Take a point here. X is 3, y is 1. Take a point here. X is 4, y is 2. Take a point here. X will be 4, y will be 3. So throughout the green zone, and this is important, the line of kink divides the area in 2 parts. The right hand side of the zone is where x is greater than y. That's the first part. So we go ahead and we just jot down this. Now the second part is where x is less than y. Y is more than x. Take a point like this. X is 1 here. Y is 3 here. So all these points represent x less than y. And we just formulated that whenever x is less than y, the utility is always derived from x. So whenever x is less than y, which means in this zone, my utility is always the line of x. So I draw a line through x by holding x constant. Similarly, when x is greater than y, my utility is always derived from y. So I draw a line through y. And when x and y are equal, then it's just that point where I am on the king. So this actually goes ahead and defines the same L shape, which says that in the zone where x is less than y, you have your utility defined by the line where x is consistent or x is constant. When x is greater than y, you have a line of u equal to y. And that is what we are doing geometrically. Here I am saying x is equal to 2. This is a line where x is equal to 2. This is a line where y is equal to 2. So I'm actually defining a line utility only by x. Right? This is how we draw lines. When I say draw a line that x is equal to 4, what will you do? You will say, okay, x is held constant at 4. This is my line. And whenever x is less than y, I just have to focus on the line of x. Whenever x is greater than y, I have to focus on line of y. So this gives me this L-shaped curve. This is how we draw the shape of complementary goods. Now, one property of complementary goods is that whatever comes inside the main function is equated. You will always consume in that ratio. X will be equal to y. But I know that I cannot just keep consuming infinite. I cannot say that I am consuming 100 units of x and 100 units of y, 500 units of x, 500 units of y. I am being constrained by my budget line. So although I have to consume equally, I have to consume x equal to y, but my budget line is px into x plus py into y equal to m. This is the constraint that I have. So if in my constraint I put x instead of y, because the two are equal at equilibrium, I can say px into x plus py into x is equal to m. So I can take x common and I can get px plus py equal to m. From here, I can get x star is equal to m by px plus py. You know x is equal to y, so y star is also equal to m by px plus py. You should do enough practice of deriving the Marshallian demand curves so that if in exam you get a question related to these curves, at least this basic answer you should know. That comes with practice. You should know that it is m by px plus py when x is, when I have a function min xy. Now, had my function been min ax comma by, I would have just said ax is equal to by. So y would have been a by b into x. Instead of y, I would have substituted a by b into x. Everything would have been in terms of x. You would have found the value of x. So here, you can now literally do it for anything. Your min function could have been min of 4x comma 7y. Equate 4x equal to 7y. Y is equal to 4 by 7x. Instead of y, put 4 by 7x. Get entire function in terms of x. Solve for the value of x. So, you just have to remember what is the procedure that is followed in case of complementary goods. Now, once I have found X star and Y star, these are my Marshallian demand function. The next thing will be to go ahead and find utility. So utility is basically min of x comma y. I have got a value of x. This is min of m upon px plus py, comma m upon px plus py. X and y are same, so the min is the same number. So you will get m upon px plus py. So your indirect utility function will be this. Indirect utility function. It will be a good idea to go ahead and see if the properties that we suggested yesterday still hold true for this indirect utility function, which means you have to go ahead and verify if it's increasing in income, decreasing in prices, and homogeneous of degree 0 in income and prices. So you just verify these properties. Here it's coming in the numerator. So when you differentiate, you will get 1 by px plus py, which is greater than 0. Here it is coming in the denominator. So when you differentiate, you will get minus 1 by px plus py whole square into m less than 0. Here when you multiply, instead of m, you write pm. Instead of px, you write tpx. Instead of py, you write tpy. You can take t common. So this is simply t to the power 0 into the initial function. So therefore it is of degree 0. So which means that the properties that we did yesterday for Cobb-Douglas function, that it is non-decreasing in income, non-increasing in prices, and homogeneous of degree 0 in income and prices, hold true even when we move away from Cobb-Douglas function and go towards the complementary goods. Right? So now we have done step 2, where we have found IUF, indirect utility function. Let's find expenditure function from there. So my indirect utility is V is equal to M by Px plus Py. From here, my M will be V into Px plus Py. This is nothing but my expenditure function as a function of prices and utility. I'm holding utility constant at U bar, so Px plus Py. This becomes your expenditure. Expenditure function is just rewriting the indirect utility function. I could have written V itself here. I'm just writing U bar because that's the technique that books use. They usually write U bar to represent a same level of utility, a constant level of utility. Had you written V here, it would have been fine. Nothing wrong with that. You're just representing it by utility. So it's fine. So this gives you the expenditure function. Now, once you have the expenditure function, the next part is to go ahead and find Shepard's lemma, using Shepard's lemma, the Hicksian demand function. So do that once. Just derive this using Shepard's lemma. Hicksian demand of good X will be del E by del Px, which will be U bar. Hicksian demand of good Y will be how expenditure changes with PY, which is again U bar. So this is my Hicksian demand. So we have been able to solve the entire question. We started with min function. We found out what is their Marshallian demand. We used those Marshallian demands to go ahead and find what will be indirect utility function. From indirect utility function, we found out what will be expenditure function. From expenditure function, what would be Hicksian demand. That finishes this complete part. Now, diagrammatically, you would have gone ahead and represented it like this. This is my budget line. If I look at my budget line, this is M by PX, M by PY. I want to go and attain the highest indifference curve possible. Is this the highest indifference curve? No. I can go above. Is this the highest indifference curve? Yes. Is this the highest indifference curve? No, this is not within my budget. So this is the highest indifference curve that you attain, and this is the point of equilibrium which happened at the kink. Again, proving that equilibrium happens when x is equal to y. This is very, very important from exam point of view. The entire min function and substitute good functions. Okay. Any doubt in this before I go to substitute goods? Anything you want to ask? Okay. We'll go to substitute goods then. In case of substitute goods, I am saying that I have goods which can be used in place of one another. So, for example, tea, coffee, for example, ball pen, gel pen, etc. Now, the usual way of writing substitute goods is U is equal to AX plus BY. This is a general form. But I'll take first of all the case where simply I'm having XU is equal to X plus Y. I'll talk in detail about AX plus BY, maybe today or in the next class. In fact, a little complicated case than this also. But let's begin with this general case where I have U is equal to X plus Y. If I ask you, what is the MRS of this utility function? MRS in absolute terms, leave the negative sign, will be MUX by MUY, which is nothing but how utility changes when X changes upon how utility changes when Y changes. So how is utility changing when X is changing? Differentiate with respect to X, you'll get 1. Differentiate with respect to Y, you'll get 1. So the answer is simply 1. Now, if I have to plot these indifference curve, I can hold utility constant at 4 and I can get 4 is equal to X plus Y. This is clearly a line. So when X is 0, Y is 4. Y is 0, X is 4. X is 2, Y is 2. So if I have to draw this indifference curve, I will get 1, 2, 3, 4. This will be my indifference curve. This represents utility at 4. You can have different indifference curves. This represents utility of 3, this represents utility of 2, utility of 1, and so on. So these are my set of indifference curves, as we call it as the indifference map. Now, with substitute goods, we have various cases that we have to see. This case usually depends on what is the ratio of prices and MRS XY. The ratio of prices is nothing but the slope of budget line. This is nothing but the slope of indifference curve. We have to see whether the slope of budget line is less than the slope of indifference curve, greater than the slope of indifference curve, or equal to the slope of indifference. To do that, what we do is the following. So we begin by saying that the ratio of prices is Px by Py. MRS XY I will write as is. And I will take the first scenario when this is less than MRS XY. In my case, I found out that MRS XY is simply 1. This depends again, okay? Had my function been AX plus BY, then my MRS would have been A by B. Differentiate with respect to X upon differentiate with respect to Y. In this case, when I differentiated, I got 1 by 1, so the answer is 1. So, my first case is when Px by Py is less than MRS. Here, I can rewrite this as Px by Py less than 1 because my MRS is just 1 in this case. This gives me Px less than Py. And this tells me that whenever price of good X is less than price of good Y, and because they're substitute goods, you can either use X or Y. You can either use a ball pen or a gel pen. You can either drink coffee or tea. So because they're substitute goods, whichever good is cheaper should be bought because you can buy more of it. If a gel pen costs you 10 rupees and a ball pen costs you 5 rupees, you'll go for a ball pen because you can buy more of the ball pens. So here in this case, because my Px is coming less than Py, I get the situation that I should buy only good X because X is cheaper. So because I am buying only good X, if I go ahead and write my budget line, Px into X plus Py into Y is equal to M, instead of Y, I can write 0 because I'm buying only good X. X and Y are substitutes and X is cheaper. So plus Px into X is equal to M, or Px into X is equal to M, X is equal to M by Px. So I get my first scenario here that when Px by Py is less than MRS XY, then you should consume only good X, which means X star will be M by Px and Y star will be 0. Let's see what this means diagrammatically. See, please understand that Px by Py is less than MRS XY. In this case, indifference curve and budget line are both lines. Indifference curve is not a curve. I don't have any tangency point. They're both lines, but with different slopes. So one will be flatter, one would be steeper depending on their slopes. So I give you the simplest way to check when is a line steeper and when is a line flatter. Supposedly, I take Px by Py as half and MRXY as 1. Clearly, half is less than 1. Now, notice what I'm going to do. Half means perpendicular is 1 and base is 2. So perpendicular is 1 and base is 2. 1, 2. This is your budget line slope. Here, because it is 1, perpendicular is also 1 and base is also 1. So you have your indifference curve aligned like this. So clearly, this is a flatter line. Whichever line has a lower slope is always flatter. Supposedly, we take the other way around. Let's say that Px by Py is 4 and MRS xy is 1. Then 4 means 4 by 1 and 1 means 1 by 1. So in this case, I am saying, how do I draw this budget line? It is 1, 2, 3, 4. Perpendicular is 4. It's always perpendicular by base. Base is 1. So this is my budget line. Give me a second. Okay. And in the other case, I am saying MRS xy is 1. So perpendicular is 1 and base is also 1. So you get it like this. So clearly this becomes steeper and this becomes flatter. Whichever line has a lower slope will be flatter. Whichever line has a higher slope will be steeper. Now, let's go to this case first. So I'm still doing the case that Px by Py is less than MRS xy, which means my budget line is going to be flatter. So Px by Py less than MRS xy. This means that my budget line would be flatter. So I draw this as the budget line. Okay, this is my budget line. My indifference curve was steeper than this. So maybe this is my indifference curve. This is my indifference curve. Now I ask a very simple question. Which is the highest indifference curve that you can reach while you stay within your budget, while you spend money within your income level? Is this the indifference curve? The answer is, I can go on a higher indifference curve. This spends some part of my income. It's on my budget line, but I can go higher and still be on my budget line. I can go higher. Even here, I'm spending equal to my income. I can keep going higher until I reach this point. This is also on budget line, but I am on the highest indifference curve possible. Can I go higher? No, because then I would be above my budget line. No point of the indifference curve will touch the budget line. So when Px is less than MRS xy, I reached a point of equilibrium, which is here. This is the highest indifference curve I have reached. And at this point, I see that I am consuming only good X and no good Y. Well, exactly what we analyzed mathematically. That when Pxy was less than MRS xy, I was getting price of good X less than price of good Y, and I was consuming only good X. And in that case, my consumption of good X was M by Px. Exactly what we interpreted. So we have got the same thing diagrammatically also. Now let's reverse this. Case 2. Here I am saying Px by Py is greater than MRS XY. Now think what should happen. So if Px by Py is greater than MRS XY, I should be saying that Px by Py is greater than 1 because my MRS XY is 1. So which means my Px is greater than Py, which means good Y is cheaper. So I should consume only good Y. So in this case, if I go back to my budget line, which is Px into X plus Py into Y is equal to M, instead of X, I will write 0 plus Py into Y is equal to M, and I will get Y star is equal to M by Py. And I will get X star is equal to 0. You should try and analyze the same thing diagrammatically also. Why am I emphasizing diagrammatically? Because when we do complicated questions, it is only the diagrams that help us to understand where will I reach my equilibrium. So diagrammatically, I can go ahead and say that my budget line is now steeper because it has a higher slope. This is flatter indifference curve. So I draw my budget line first. And then I start plotting my indifference curves. So this is my indifference curve. Is this the highest indifference curve? No. I can go higher. I can go higher. I can go higher, higher, till I reach this point. This is the highest indifference curve, which is within my budget. And this point, I'm consuming only good Y. So this is where Px by Py is greater than MRS XY. Budget line is steeper than the indifference curve, and you consume only good Y. Now let's take case 3. Case 3 is what happens when Px by Py is equal to MRS XY. If they have the same slope, then they are the same line. So what I am doing is, I am saying that this is my budget line. My indifference curve has the same, it's a parallel line, it's the same slope as the budget line. Which is the highest indifference curve I can reach? I can go here, I can go here. This is the highest I see possible when it coincides with the budget line. And when I am on the budget line, my X can be anything between 0 to its maximum value. I can consume a point here where I'm only consuming X. I can consume a point here, a point here, a point here, or a point here where I'm not consuming X at all, where X is 0. And once you decide on X, then you can put that value of X in the budget line equal to M and get a value of Y. So Y will simply be M minus Px into X by Py. If you decide, for example, that you don't want to consume X, then Y will be M minus Px into 0 by Py, which is simply M by Py. So it will be this point. If you want to consume X exactly half of your income, so your Y will be M minus Px M by 2 by Py. So different combinations. If you want to consume entirely X, then your Y will be M minus Px, M by Px by Py, which will be 0, which will be this point. can vary to any amount here. You can consume any combination of X and Y because they have equal price. If they have equal price, I can distribute my income half-half on both of them. If they have equal price, I can just still consume one of them. I can consume the other of them. I can make any combination possible. So we have 3 cases in totality. Case 1, when Px by Py is less than MRS XY, in which case you consume only good X. So your X star becomes M by Px and Y star becomes 0. Case 2, where Px by Py is greater than MRS XY, your X star is 0 and Y star is M by Py. Case 3, where Px by Py is equal to MRS XY, X star is anything between 0 to M by Px, and Y star is the remaining amount, M minus Px into Xy. This is your Marshallian demand. Once you have found the Marshallian demand, you have to go ahead and find the indirect utility function. What is indirect utility function in this case? Your utility was X plus Y. So when you have Px by Py less than MRS XY, so you were having X equal to M by Px, Y equal to 0. So X plus Y will be M by Px. When you had Px by Py greater than MRS XY, in that case your X was 0, your Y was M by Py, so your utility, which is sum of these two, will be simply M by Py. And then there is case 3, when Px by Py is equal to MRS XY. In this case, you can consume any amount of X, any amount of Y. So your X was anything between 0 to M by Px and Y was M minus Px into X star upon Py. You can add these two and get the indirect utility. Now, please see that my indirect utility function is either M by Px or M by Py, or this, which will also come out to be either M by Px or M by Py or something in between. So I'll take two extremes. When X is 0, it will come M by Py. When X is M by Px, it will come M by Px. Right? So it will be between these two values. If I have to give one line, one formula to represent these two things, then what can I really write about them? That my utility, indirect utility, is either M by Px. This happened when Px was less than Py, or it is M by Py. This happened when Px was greater than Py. So whenever Px is less than Py, I get Px in the denominator. Whenever Px is greater than Py, I get Py in the denominator. Can I go ahead and say that my indirect utility function is m upon what I get in the denominator will depend on whichever is minimum, whether Px is less than Py or Py is less than Px. So m upon min of Px, Py. This indirect utility function takes care of all possible scenarios. When Px is less than Py, then min of Px and Py is Px. And I was getting this as the utility function, m by Px. When Py is less than Px, then min of Px, Py was coming as Py. And I was getting this as my utility function. And in the third case, it can be either of this. You can put an equal to sign here or an equal to sign here. That's fine. So your indirect utility function precisely can be written as m by min of Px Py. This is something that has come a lot of times in different entrance exams. You would not be given a function like this. You would directly be given something like this. And you would be asked, which of the following goods have this kind of utility function, m upon min of Px Py? Now from here, you can go ahead and find the expenditure function. Just rewrite this thing. So you will have indirect utility is equal to m upon min of Px, Py. So from here you will get m is equal to min of Px, Py into u bar. So you will get expenditure function as a function of prices and utility as min of Px, Py into u bar. This becomes your expenditure function. Please think about this once. Is there any doubt that you want to clarify? This is very, very important. Because from here, I'm just going to build upon this. This is going to act as a base for me. So you have to understand how I derive this indirect utility function for substitute goods. And then I've just rewritten it to find the expenditure function. But this in the background had various cases. Px by Py less than MRS, Px by Py greater than MRS, etc. You have to understand all these cases very well. Now, I've got my expenditure function. There is just one last step left. I have to use Shepard's lemma and find out Hicksian demand function. So I go ahead and I use the Shepard's lemma and I find Hicksian demand function. What is Hicksian demand function? Demand in terms of utility and prices. What is Marshallian demand function? Demand in terms of income and prices. So for Shepard's lemma, I say case 1, if Px is less than Py, then my expenditure function will be min of Px and Py will be Px into u bar. So, my x will be how expenditure changes when Px changes, which will be u bar. And my y will be how expenditure changes when Py changes, which will be 0. So when Px is less than Py, Hicksian demand function for x is u bar, for y it is 0. Take the other case now. If Px is greater than Py, then min of Px and Py will be Py. So your expenditure function will be Py into U bar. In this case, again, your Xh will be how expenditure changes when Px changes, which will be 0. And your YH will be how expenditure changes when Py changes, which will be U. So when Px is greater than Py, then min of Px and Py is Py. Then your expenditure function is Py into U bar. And your Hicksian demand is 0 and U bar respectively. Take the third case. If Px is equal to Py, then your expenditure function can be written as anything. You can write it as Px, you can write it as Py. So you will simply have Xh equal to U bar, YH equal to 0, or Xh equal to 0, YH is equal to U bar, in case you write it as Py into U bar, or any combination in between also. So you can have anything in between because the two are equal. So this is actually the scenario of substitute goods. This is very, very important. You won't be asked directly to derive substitute goods. Substitute goods would be within some part. It would be given in some different format from which you'll have to solve that utility function to get to the level of substitute goods, and then from there all this continues. So you have to be very thorough with the parts where we did the basic min function, substitute good function, we'll do max function, quasi-linear, so that whenever I pick up a complicated question and I simplify it to the form of substitute goods or complementary goods, from there you can pick it up and you can do all these steps. I will not be doing this continuation of the steps from there. Okay. Now, let's do a third kind of utility function, and they actually act very, very similar to substitute goods. They're very similar, and they're known as my max functions. So the max functions have a utility function that looks like max of x or y. What is one property of these max functions? These functions represent goods which give you positive utility. However, the two goods cannot be consumed together. For example, milk and wine. Milk gives positive utility, wine gives positive utility, but you cannot go ahead and consume milk and wine together. You cannot consume X and Y together. So even when the prices of X and Y are equal, either you will spend only on X or only on Y. You will not have a combination that you can consume. Unlike substitute goods, where when tea and coffee have the same price, you can spend half of your income on tea and half on coffee. You cannot do that with max goods. Max goods have this property that you don't consume them together. Even when the prices are the same, either you go with only X or you go with only Y. So how do we write these max functions? Now, to solve this, I'm again going to take three cases. I can have X less than Y. When X is less than Y, max of X and Y will be Y. So my utility will be simply Y. I can have X greater than Y. So my utility will be max of XY, which is simply X. I can have X equal to Y, in which case I just get my point of Q. I can have X less than Y, max of X and Y will be Y. So my utility will be max of X Y, which is simply X. I can have X equal to Y, in which case I just get my point of Q. I can have X greater than Y. So my utility will be max of XY, which is simply X. I can have X equal to Y, in which case I just get my point of Q. So how do I go ahead and draw the indifference curve for this? Now again, this is my line of kink. The line of kink is always derived by equating what comes inside the max function. So here I have equated x equal to y. This is the zone where x is greater than y. This is the zone where x is less than y. When x is greater than y, then you have u equal to y line. So you have a line of y here. And when x is less than y, you have u equal to y. So when x is less than y, you have a line at y. And when x is greater than y, you have a line at x. And this is the point of k. So the utility function for a max code is inverse L-shaped. And this makes sense. Take this example. For example, I have 4 here. I have 4 here. And this is a point which is 4, 4. So the max of 4, 4 will simply be 4. But suppose I take a point here. This is x is 4, y is 0, but the max is still 4. So it gives me the same utility that I'm getting at the point of kink. Take a point here. Suppose this is x is 4, y is 1. So max of 4 and 1 is still 4. So this point also gives you the same utility as this point and this point. This point is y is 4, x is 0. Again, I have to find max of 0 and 4, which is 4. So all these points give you the same level of utility. And because they give you the same level of utility, they have to be on the same indifference curve. That is why you get this as your indifference curve. Now, here, unlike the min goods, the max goods act very similar to the substitute goods. So I take case 1. And this case is when Px is less than Py. If price of good is less than price of good y, it can be like maybe my x is milk, maybe my y is wine. So if Px is less than Py, then I'm going to go ahead and consume all of milk. Because it's simple. Both of them are giving me positive utility. I cannot consume them together. So I will consume the one which is cheaper. How do I show this? Supposedly, because Px is less than Py, I get from here a budget line, which is, let's say, Px by Py less than 1. So let's say my Px is 2, my Py is 3, and this is less than 1. If I have to jot down the budget line for this, this is 1, 2, 1, 2, 3. This is my budget line, 2 by 3. You should always take some numbers to draw the budget line. That way it is always simpler to draw it. So I understood that Px is less than Py, which means Px by Py is less than 1. So I can simply take Px as 2, Py is 3. You could have taken anything. Px as 3, Py as 4, Px as 4, Py as 5. You will get this as the budget line. Now, I have a line of kink passing through x equal to y. All my indifference curve are L-shaped along this line of kink. So this is my indifference curve. This is also my indifference curve. This indifference curve, it touches the budget line, which means it consumes at this point all of your income because it has a point on the budget line. But is this the highest indifference curve that I can reach? No. I can go to an indifference curve which has point at 3, 3. This point is also on the budget line, but I am on a higher indifference curve. This was giving me a utility of 1. This gave me a utility of 2. This gave me a utility of 3. So I'm on a higher indifference curve. And to reach this indifference curve, where am I? I am on a point where I consume only good X and 0 units of good Y. So that becomes my equilibrium. So when Px is less than 1, Px by Py is less than 1, or good X is cheaper than good Y, I get my equilibrium where I consume only good X and 0 units of good Y. That becomes my equilibrium. Now take the reverse way. When Px is greater than Py, then good Y is cheaper. So you consume only good Y. But while I am doing this, don't we realize that the max goods are acting very similar to the substitute goods? When price of good X is less than good Y, you consume only good X. When Px is greater than Py, you consume only good Y. So aren't we acting very similar to substitute goods? With only one exception, that when Px is equal to Py, even when the prices are equal, either you spend all your income on X or all your income on Y, but not a combination of them. Otherwise, they're acting as substitute goods. Whichever is cheaper, buy that, you will get more of that. So here, I can go ahead from here and solve it exactly like substitute goods. My Marshallian demand function will be when Px is less than Py, X star is M by Px, Y star is 0. When Px is greater than Py, X star is 0, Y star is M by Py. You just put here X star equal to 0 in budget line, you will get this as Y star. And when Px is equal to Py, Px, then either you get this M by Px comma 0 or 0 comma M by Py. Nothing in between. That's your equilibrium. So, because they act very similar to the substitute goods, the indirect utility function for the max goods is same as substitute goods, M upon min of Px comma Py. When Px is less than Py, then you are getting your utility as M by Px. When Py is less than Px, you're getting your utility as M by Py. Why? Because once you have got this X and Y, your utility was what? Max of X and Y. It was max of X star and Y star. X star is M by Px, Y star is 0. So its max is simply M by Px. Here, max of 0 comma M by Py is simply M by Py. So your utility that you're getting is simply M by Px or M by Py It is m by px when px is less than py. It is m by py when py is less than px. And from there, you get your indirect utility function as this, m upon min of px comma py. So you don't have to really solve for max functions. Max functions act very similar to substitutables. Although they're not substitute of each other. You're not saying that milk is a substitute of wine. Still, the good property about them is that they cannot be consumed together, just like substitutables. With a slight difference that they don't substitute each other. So, you will only consume the good which is cheaper. And therefore, you will get a utility function, indirect utility function, expenditure function, everything very similar to the substitute goods. Is there any doubt in this? Anything you want to understand? They're very important functions. Okay. Now, let's go to the last item. These are called quasi-linear utility functions. Now, what is quasi-linear? First of all, what is the word quasi? What does that quasi mean? So, quasi word actually means partial, half, near to linear. So, quasi-linear utility function has two parts to it. One part is where we have the linear aspect, and the other part is where we have the non-linear aspect. So one of the goods that we have is linear, and the other goods that we have is non-linear. Now let's see how do we write these utility functions. Just give me a second, please. So this is my utility function. U is equal to root x plus y. X here is coming non-linearly and y is coming linear. Let's see how to go ahead and solve this kind of utility function. So what I'm going to do is step 1, I will again go ahead and solve using Lagrange. So I form a Lagrange and I say that my utility that I have to maximize is root x plus y, and my constraint is my usual budget constraint, so plus lambda m minus px into x, py into y. Remember, there is no compulsion. You can do this also with the method of substitution. You can do this also with the method of equating MRS to Px by Py and putting that in the budget line. I follow Lagrange because I can generalize it for all my problems. I will follow Lagrange throughout. So now you differentiate this with respect to x. You will get 1 by 2 root x plus lambda minus px is equal to 0. So from here, your first equation will be 1 by 2 root x is equal to lambda px. You differentiate this with respect to y. and you will get 1 plus lambda minus py is equal to 0, which means you will get 1 is equal to lambda py. This is equation 1. Equation 2. You're going to go ahead and divide 1 by 2. So you will get 1 by 2 root x by 1 is equal to lambda px by lambda py. So your lambdas would get cancelled and you will get 1 by 2 root x is equal to px by py, or you will get x star is equal to py by px into 2. This will be your x star. Now, can you go ahead and identify something which happened differently in this case when you found out x star? One thing that didn't happen till now whenever we were finding x star, but this is the first time when I see very different value of my x star. What is that one thing that is missing from this x star? Any hint, anything that you can think of that is missing from this x star? Well, this x star, unlike all the Hicksian demand functions that you had found out, has missing m. Your x does not, in this case, depend on your income. It is not affected by the income level. So because in this case, x is not affected by income, what are we really saying? We are saying that the optima x does not depend on what your income is. You will always buy it. So x actually acts like a necessity good. It's like salt. It's like the basic toothpaste. It's like toothbrush. You will buy these goods irrespective of your income. You will buy salt irrespective of your income. That's the basic thing required for survival. So x does not depend on the income level. Now, if instead of this, let's go ahead and find out the value of y. So what is your y? Y is nothing but m. So how do you write your budget line? Your budget line is px into x plus py into y is equal to m. In this case, I am getting my x as py by 2px whole square into px plus py into y equal to m. I'm just replacing x from here, from this value. I'm just replacing it here. So I will get px into py square by 4px square plus py into y equal to m. And just find y from here. So you will get y is equal to m minus py square by 4px 1 by 2. So you will get y equal to m minus py by 4px by. This will be your value of y. Y is not a necessity good. Y depends on the level of income. See here, y depends on m. Y is not a necessity good. But it is x which is a necessity good. X does not depend on income. X will be consumed irrespective of the level of the income. But that does not hold for y. Now, from here, let's just solve this y a bit more. So I will get y star. If I just take denominator common, I will get 4px py. Here I will get 4m into px minus py square. Now here is the thing. See, px and py, they are positive numbers. So px into py is positive, into 4 it is positive. So the denominator is always positive. But let's just for a second think about this numerator that we have here. The numerator that we have can be negative, 0 or positive. What if this numerator 4mpx minus py square is either 0 or less than 0? What if this numerator is either 0 or less than 0? Then in that case, your y cannot be negative. You cannot consume negative quantity, but it will come out to be negative or 0. So in that case, your y would simply be 0. So if your numerator is negative or 0, y star will be 0 because you cannot consume negative quantity. If y star is 0, then you're spending your entire income only on x. In that case, if you look at your budget line and instead of y, you go ahead and you put 0, you will get your x as m by px. So your quasi-linear function has two answers. Answer 1 exists when the numerator of this y is positive. So when 4m px minus py square is strictly positive, then in that case you will consume x star as py upon 2px whole square. This is what your x star came, right? Py upon 2px whole square, and you will consume y star as 4mpx minus py square upon 4px py. But if your numerator is less than or equal to 0, then your x star will be m by px and your y star will simply be 0 because the numerator is negative. This question came in one of the exams. This was asked. Suppose 4mpx minus py square is negative with the utility function root x plus y, which is the equilibrium condition. What is the value of x star, y star? This came in one of the entrance exams. So you have to solve this and understand that if the numerator is coming negative, you cannot consume negative quantities of y. It simply means that you're not consuming y. And if you are not consuming y, you are spending your entire income on good x. So x becomes m by px. And this was also one of the options, that x star is py by 2px square. But in this case, x is not this. X is this. You're spending your entire income on x. Now, once you have found the Marshallian demand, then it's simple. You can do it. Indirect utility function will be root x plus y. So in this case, it will be root of x will be root of this, which will be py by 2px, and y will be 4mpx plus minus py square upon 4 px py. This will be your indirect utility function. And in the other case, in this case, your indirect utility function will simply be root of m by px plus 0, which will be root of m by x. Root x plus y was your function, right? So this is your indirect utility function in the two cases. You can solve for income from both the sides and get your expenditure function. So from here you can find your expenditure function, and here your expenditure function will be u bar into root px whole square. This will be your value of income, right? So u bar square into px. Here also you can find your expenditure function. Equate this to u bar. So it will be u bar minus py by 2px plus py square by 4px py into 4px py by 4px. This will be your value of income. So this will be your indirect utility function. And then you can use your Shepherd's lemma and find del E by del Px and del E by del Py. Here also you can find it. Del E by del Px will be u bar square. Del E by del Py will be 0. And here it is going to be, you can solve for it and you'll get an answer here and get an answer here. This is simple differentiation. But what is important for quasi-linear utility function is this approach, this part. Most of the students just get this as the answer. They solve for x and y, but they do not take this into consideration that the numerator of y can be negative also, in which case you will not consume y at all and y will become 0. And when y will be 0, then x will not be this, but more than this. You will spend your entire income on x. So x will be m by px and not py by 2px whole square. This holds as long as you consume y also. Otherwise, this is your Marshallian demand. And accordingly, you will get two cases to find indirect utility function and expenditure function and Hicksian demands. So you have to be very careful while analyzing this question. Any doubt that you have, you should be practicing this on the very same day. If you extend this and wait for the next day, you may not be able to understand this thing. Okay, before we end the class, I'll give you a question. First, you try and then I will tell you how to solve it. This came in Delhi School of Economics 2017 paper. And quite recent. And the question said the following. You were given a utility function which was min of xy into z. So see, they have tricked the question. They have gone ahead and introduced three goods, x, y, and z. And it said that the expenditure, or simply they said that the prices were P1, P2, and P3. And the budget line was simple, P1x plus P2y plus P3z equal to m. And it said, find equilibrium level of, this is the question. And four options were given. So you're given a utility function. The utility function has a min function but only in some part. See here, it's only in some part that this utility function has a min function, not completely. So you will use the properties of what min function we did, but there is a little more to that. And then this is your usual budget line that is given to you, although in 3 dimensions. P1x plus P2y plus P3z is equal to m. And they asked you to find the equilibrium level of x. Now, whenever you would be given a function which has more than 2 goods, you will always solve it in 2-step budget. Now, what is this 2-step budget? So what you will do is the following. You will say, suppose, and carefully look what I am doing, I introduce a new utility function that only represents min of xy. This part of the utility function, I say that min of xy will be either x, either y, either x or y, depending on whatever is minimum. But I say that this part of my utility function, I represent it with some new alphabet. It can be any alphabet. So then your utility function becomes this phi into z. Okay. This is your new utility. This utility function in turn has this utility function combined. And now I say that suppose the income spent on good x and y is M1. I am introducing 2-step budget. So my total income was M. I know x and y are complementary goods. So x and y will be equally consumed. But totally on x and y, I am spending M1. And my income really is M. So which means on Z, I am spending my remaining income M minus M1. But let's just focus for a while on this M. If M1 is what I am spending on good X and Y, I can write a smaller budget saying that the income, the expenditure I do on X plus the expenditure I do on Y, that is equal to M1. I'm spending M1 on X and Y together. Now, from the exercise that we did, I'm not going to do that again, but I know that if X and Y have a utility function which is min of xy, and if this is my budget line that I have, then I know from what we did in the beginning of the class that x1 star will be m by px plus py, where m is my income spent on good x and y, so it will be m1, and y star will be m1 upon px plus py. X and y will be consumed in the same proportion. So instead of y, you can replace x here, and then you will get x is equal to m1 upon px plus py and y equal to m1 upon px plus py. This is the amount that I'm going to spend on x and y. Is this clear? I am forming a 2-step budget. My income was m. I am spending out of that entire m1 on good x and y. But since these are min function, they are consumed in equal amount. So I get the same amount for x and y. Now, if you ask me what will be this utility function in that case, this will be min of x comma y, which will be min of m1 upon px plus py, comma m1 upon px plus py, which will simply be m1 upon px plus py. This is what my utility function will come out to be. What was your budget line that was given to you? The budget line was P1 into X plus P2 into Y plus P3 into Z is equal to M. How much money are you spending on X and Y together? M1. So this part is M1. So M1 plus P3 into Z is M. So what is your M1 really? M1 is M minus P3 into Z. So instead of this M1 everywhere, I can rewrite this as M minus P3 into Z. I can rewrite this as M minus P3 into Z. I can rewrite this also as M minus P3 into Z. Now I have a value of V, which is in terms of M and Z. I will go back to my original utility function and replace this V with that value. So my utility function was V into Z. I found out a value of V, which is M minus P3 into Z upon P1 plus P2 into Z. The entire utility function is only in terms of Z. You can maximize this utility with respect to Z. So when you maximize this utility function with respect to Z, how utility changes when Z changes, equate it to 0, you will get M minus, this will become Z square. So its differentiation will be 2Z into P3 equal to 0. So from here you will get Z star is equal to M by 2P. You've got your Z star. What was X star? X star was this. M minus P3Z upon Px plus Py. So X star will be M minus P3 into Z upon Px plus Py. This will be M minus P3. Instead of Z, I will write M by 2 P3 upon Px plus Py. So your X would be M upon 2 Px plus Py. This will be your X star. This is called two-step budgeting. So notice that you are not going to get a straightforward question on min function. But you have to use the properties of the min function. You should know that if it is a min function, I have to apply kink to it. I have to consume equal amount of X and Y. That's the property that helped me to solve this. I should remember how to find the Marshallian demands of X and Y. This kind of question has been repeated 2 to 3 times in the past year in Delhi School of Economics and in ISI. I've done one time. I will do many more questions of DSC in the next class. But for that, you have to revise this, solve this question at least thrice so that you understand this question very well. What is a two-step budgeting? How do we first allocate some amount of income on X and Y, find X and Y from there, put that back in the utility function, make the entire utility function in terms of Z, and then solve for Z. So that's the two-step budgeting that we follow. So tomorrow, I'm going to introduce to you 2 very difficult, extreme kinked functions. One is min of X plus 2Y, comma 2X plus Y. The other is max of X plus 2Y, comma 2X plus Y. You will only be able to solve this if you revise what is min, what is max function, and this two-step budgeting that we did in this question.